So welcome to my presentation about applied AI with Eclipse Graphene. My name is Martin Welss. I am the project lead of this project, and I work for Fraunhofer IAIS here in Germany. So Graphene is a system about creating AI pipelines and deploying them. And the system has two distinct parts. So the first one is the portal, which has the catalog, the design studio, the deployment services. So it's basically a Kubernetes architecture. But it does not store big data sets or the Docker containers itself. So it's really the visual part for creating pipelines and the catalog. And then we have a strict system boundary towards the execution environments. So we intentionally divided this into the portal and the execution environments because usually those pipelines need to be executed in confidential environments or in specific HPC environments with GPU accelerations which are not publicly available. So this is very important to keep in mind that there is a difference between execution, running pipelines, and the configuration and the catalog and the design studio. So what we see here on the next slide is the catalog. So we have different reusable AI models. That's the idea. And those reusable AI models can be then composed into AI pipelines. And all of the models are Docker containers. And it is perfectly fine to have commercial models here in the catalog. So the project, of course, itself is open source, but the contents in the catalog, so the models that can be put into the catalog can be open source and commercial, and each of the models must have a license so that the user can see what are the conditions under which the models can be used. And it is possible to compose AI pipelines visually in our design studio. So we have one example here on the top, a training pipeline with TensorBoard integration and a shared folder. So all nodes can access the shared folder to exchange data easily. The design studio shows matching models, so it's easy to find out what can be connected with what. And here on the bottom, we see a little, a larger pipeline, which has several nodes coming from the audio domain. So this is what we at Fraunhofer, at my institute, are using. We are doing audio processing, and the pipelines could look like this, and they can be easily changed even by non-programmers. So that is one of the important part. But it can be used for training by researchers and developers, but also by non-AI experts and non-programmers to work with AI modules and create pipelines for a specific use case at once. And we have one example execution environment. This is our public AI playground. So it is not suited to process any confidential data there. It is free to use, and it allows one-click deployment. So if I choose a pipeline or a model from the catalog or the design studio, then I can, with one click, deploy it into this playground and let it run, and under the hood, all the Kubernetes stuff is taking place automatically. And this playground app is also part of the Graphene repositories. And what is also very interesting is for the development use case, for the development cycle. So by clicking reset, all the Docker containers are repulled. So if you use, for example, Docker tags for your images with the latest, and you build a new Docker container because you noticed one bug or made some improvement, then by clicking on reset, the pipeline will be repulled and the new Docker container will be automatically executed. And our container specification for composable AI modules sits on top of the Docker image specification. So all of the modules are Docker containers with additional properties. Very important is that the public interface of each module must be specified in the open protobuf format. So we use protobuf and gRPC for the communication between the nodes, between the Docker containers. That has very important advantages because it is programming language neutral and it can be automatically parsed and the stubs and skeletons for the communication can be automatically generated on the fly. Then it is also possible to incorporate into the container a web UI for that specific model so that it is possible for the user to do some configurations. So we see on the right-hand side the protobuf interface definition, which is, I would say, the business part, and then we see the UI part on the left-hand side where the user can directly interact with the model. And this UI really comes from the providers. It's built into the container, and our experience is that it's very helpful if that is provided. And so it's no lock-in. So it still stays a Docker container. It can be executed anywhere. A Docker container can be executed. And if done right, then the same Docker container really scales from small Kubernetes installations up to HPC and GPU accelerated setups. And at the very core of our execution environment is our generic parallel orchestrator. And the orchestrator looks at the pipeline definition and dispatches the messages accordingly. So it looks for the first node and then dispatches the messages from one node to the next according to the edges. And thanks to protobuf and gRPC, it can handle Docker containers that it has never seen before. So this is, I'm not aware of any other AI tool that is offering the same functionality. And we also support gRPC streaming, so which provides long-standing connections for event-based processing. So here it can be used to process sensor input, user input, media streams, and the edges of a pipeline can be served in parallel. And it's modular, so other orchestrator implementations are possible. Then our pipeline topology is a JSON file which contains nodes and edges and the Docker image tags. But apart from that, it is completely technology neutral. So when it comes to deployment, it can be, the topology is taken and transformed into the specific artifacts for the deployment environment, which could be Docker Compose. Currently, we support only Kubernetes, but in the future, it will also be Slurm for HPC computing. And it is also possible that this topology could be changed during a run, for example, to support AutoML, advanced scenarios for auto machine learning. Yeah, so during deployment, the specific configurations for an execution environment are generated. So that's part of MLOps. And we also have a shared folder where all the nodes in a pipeline can share data, so as depicted in the pipeline below. Then we have a special node that it is called the data broker. It's usually the first node of a pipeline, and it's a shallow component that does not contain the data set. It only makes the data available for the pipeline. So it is, in many cases, environment specific. So for a company or for a certain HPC system, because it could contain credentials to access a database or a network file system and so on. And there's also a prototype available for an Eclipse data space connector for international data spaces. Recently, we have released Graphene Release 1.1. So there we have updated the underlying Kubernetes components. The Playground app is now much faster. We have more support for protobuf features like enums, one-off recursive message definitions. So one of those definitions is in the picture on the right, where expression is repeated as the expression list in the middle. And also nested definitions, so when enums are defined inside message definitions, for example. We have even better support for directed cyclic topologies. That's quite important. We have the new Jupyter Connect feature in there. We have the first steps for reproducibility and for benchmarking, so to collect metrics. And coming back to the cyclic properties of our topologies, we are aiming at supporting cognitive architectures. So we see now with LLMs, we need to combine them with different technologies of AI, with more or less traditional AI, like planning, logic, knowledge graphs, filtering is very important, object detection, OCR, and audio processing for all kinds of perception. And for this, feedback loops are important. So we need cycles in graphs that need to be supported. That's a fundamental property of cognitive architectures. So this is very important, and so we go beyond. Traditional workflow engines usually support directed acyclic graphs, so cycles are not allowed, but we definitely and intentionally allow them. It's also important that we support recursive data structures. That's also in many cases important for handling AI applications and AI models. So here on the image is from the Maze Planner, which is one of our most advanced pipelines in our AI4U experiments environment. Then we have new Jupyter Connect for interactive model exploration. So if the user chooses to deploy a single model, not a pipeline, but a single model, then the system automatically generates a suitable Jupyter Lab container, which contains already the stubs and skeletons for the gRPC communication. There is even a notebook page automatically generated where the interface is included, the protobuf definition to look it up, and also an example how to access the model. And there's also automatically added a shared folder that enables then to access a common data store for the model and for the Jupyter Hub. Yeah, so this allows for easy interaction with maybe a foreign or still unknown model to the user. Then we are collecting metadata for benchmarking. So, for example, we collect data about CPUs, GPUs, RAM, and about metadata about the data sets, so that it is clear what data set has been used. We also collect the Docker image checksums so that it can be afterwards compared if another pipeline run really uses the exact same image, or if it's a different image checksum. We support different metrics, so for classification training metrics, or classification testing metrics, or for predictor metrics, and so on. So that is important. There can be many different metrics, and this is all described in more detail in our container specification. The links for all this are at the end of my presentation. Then we are planning in the near future to support challenges, so very much in the way of Kaggle is supporting and handling challenges, but of course built on our container specification and pipeline definitions. And they are special kind of catalogs. So Graphene supports multiple catalogs, and they are combined into one big catalog that is then shown to the user. And we chose to use special kind of catalogs to implement challenges, and then a special view of the catalog called the leaderboard then orders the members of this catalog according to a specific metric. So this can be defined then by the administrator what metrics should be taken to order the leaderboard. Then we are also using LLM pipelines. So it has been, of course, more important in the last 12 months since ChatGPT came up. For example, we are working on a pipeline to ground an LLM with knowledge graph. And we are also working on LLM pipelines that actually enhance Graphene itself. So to provide to the user a more interactive way to the documentation. We are working on this kind of pipeline where a long chain is also used, and we generate the document. We are fine-tuning the output of the language model. So this is where we actively are working on. And I also want to describe some of the use cases where we actually can use Graphene. So in the general case, we can build AI pipelines from reusable AI modules, of course. But more specifically, it can be used in AI research for model training, for benchmarking, for exploration with Jupyter Connect. It can be used for education, so to give practical live demonstrations or student exercises in the playground together to combine it. We have some support for MLOps, for simplified deployment, and for training pipelines, for data cleaning pipelines, and it can support many more tools for deployment. So the deployment could be adopted to, for example, a DVC for the data versioning tool, and also for different tools that support capturing different metadata. Then, of course, it can be used just as a showcase, as a catalog to showcase internal and external models that are available. Then for application use cases where non-AI experts can compose pipelines and deploy pipelines for their business domains. And we support mixed teams, where teams can work together on a pipeline and deploy it for developing proof of concept. And it can be used for automated certification. So this is also a very interesting use case, because certification becomes more and more important, and currently there is much manual work involved. And usually over the lifetime of an AI model, it has to be recertified each time a new version comes out. So automated certification is very important, and this is easy giving the features of Eclipse Graphene. So, Graphene is being funded by many research and European funded projects. So we have the funding assured at least until 2028. And the most important ones are KI-NRW, which is a regional initiative in North Rhine-Westphalia, one of the federal states here in Germany. There is Welss AI, very important and very interesting project that wants to provide HPC and access to HPC for more people, to make it easier to access HPC systems like Jülich or in Aachen. We have Human AI Net, which sponsored, for example, the Jupyter Connect feature and also the challenge and benchmarking features. And there is also the AI on Demand platform, which is a long-running set of projects to create a platform in Europe regarding AI. So it should be the one-stop shop for AI in Europe. That's the aim. And also AI for Europe, which is one of those projects that contribute to the AI on Demand platform. And there will be a new, quite big project, which is called Deploy AI, starting in 2024. So here we have useful links for one of the running instances, which is AI for experiments, which I can show in a moment. We have the KI-NRW AI Lab. Then, of course, the links to the Graphene project on the Eclipse project page, and also the Eclipse Graphene GitLab pages, our container specifications, and we have tutorials also, one specific repository. And I want to emphasize, it really is an open project. Everyone can contribute, and if you think it is interesting for you, then please contact me. We can provide development, the development environment, and also help with tutorials and meetings. So we are happy if anyone contributing. And then at the end, there are also my contact details. I now want to show quickly a running demo. So here we have a Graphene instance which is called AI for Experiments, which belongs to the AI for Europe project. And here in the marketplace, we have currently more than 300 models and pipelines. Okay, it takes a little time. It takes more time than expected. Okay, finally. Now we can see all of the of those tiles represent one model or a pipeline, and each of the pipelines has information in the model details. So we have a description. We also have the license profile, which is being loaded. So this is what every model must have. And here we have the protobuf specification for the public interface, which is used to dispatch the messages. And we also have the model artifacts Those are the files that belong to it. So for example, we have here the Docker image tag, the full tag, which is transferred into the execution environment to actually pull the image. We have the protobuf definition, we have the license specification, and we also have author and publisher details in case one user wants to contact or even buy the model. And then in the design studio, so usually it's faster. I'm sorry for that. Finally, and here we can select one of the solutions, maybe the Sudoku solver, the Sudoku tutorial stream, which has 3 nodes, and it allows to solve Sudoku puzzles. And I can deploy it now with 1 click to our playground. And let's see if this is now also very slow, but it's really just 1 click. I have to authenticate. And we see here now the nodes that have been, the containers that have been pulled, and automatically added is the orchestrator, which is needed to actually do the execution. And we can then run the pipeline to start the pipeline. And if it's running, if the status changes, hopefully. Now it's running. I can open the web UI into that container, in the UI Docker container, and I can input the numbers here, and you can see that immediately the response for the solution is being presented. So I can add more colors here and more numbers here, and for example, if I input an illegal number, another 8 for example, you see that it is automatically detected that this Sudoku has no solution. Okay, and then we have also here the execution metadata, which is automatically generated to capture the metrics and the system information. So this is used for benchmarking and for reproducibility. And this is the first step in this direction, but it will be based on this kind of information. Okay, so that was my presentation. Thank you very much for attending, and do you have any questions? Yes, please.
How do you compare the graphene to Dinosaur, which has a similar pipeline as well? With,
to what?
Dinosaur, it's called.
Oh, I'm not aware of it.
I believe apart from the recursive part of the models, it had also a kind of similar workflows. It's not that I know much about it, I just wanted to know that a colleague of mine was using Dinosaur on the project, and I just wanted to see if this would be
okay. So sorry, I cannot say anything about it, but probably I will look it up. Yeah, please.
A related question would be what makes graphene unique? As you mentioned, there is the gRPC streaming.
Yes, for example.
In other, let's say, AI pipeline tools?
No, gRPC I have not seen in any other tools. In most other pipelining setups for AI, you have to write, to code the pipeline actually in Python usually. So in Kubeflow, for example, there is some limited graphical support, but usually you have to, in LangChain also, you usually have to actually code the pipeline. And more importantly, we have the cyclic topologies and our generic orchestrator, which really is able to execute pipelines with containers it has never seen before, because gRPC makes that possible. Yes, please.
Do you, what's the concept behind the data catalogs? I mean, you showed a sort of a placeholder for data being brought in, a CSV file. But I mean, most AI pipelines spend a lot of their time processing or converting the data. So in this case, is the data, you're trying to put a marketplace there for people to download the AI solution, but if isn't it going to be tightly coupled to the data source, and how do you deal with that?
Yes, exactly. So that's what we figured out. There are two things. First, we need to identify the starting nodes of a pipeline, and we call those data brokers because they have the specific property that they have no input message defined. So it's an empty input message. They have no incoming edge. So that's important. And we figured out that the access to the data is usually very tightly coupled to the execution environment. And to make this data available, that's the purpose of the data broker. So it really does not contain the data. It only makes the data available. So if you want to prepare data, that would be a separate pipeline where you can have a data augmentation or preparation or cleaning steps in a separate pipeline.
If I wanted to use an existing AI component, I would have to create my own data broker that would attach to my data source and prepare the gRPC stream for the start of the pipeline.
Exactly, and we have examples for that in our tutorial. So it's easy to use or to adopt one of our data brokers for this kind of stuff. Any other questions? Yes, please.
Do you store any of the intermediate results so that you don't need to rerun the whole pipeline again?
So when we look at the execution run, the idea is to store this execution run data then back in the Graphene catalog along with the model, which allows us to compare execution runs from one model or even different models and do ranking. So this is important for reproducibility and benchmarking and challenges. But it's really the next step. So probably before Christmas we will have it ready that the execution run is uploaded automatically or on demand. Probably we let the user decide if she wants to upload, if it is worth to upload the execution run back to the catalog. But this data can also be generated in different environments. So of course it can be generated in HPC environments to have comparisons also from different hardware setups. So that's the idea behind. Yes?
How does Eclipse help with Graphene? Is it for better publicity and transparency? I see you have lots of funding until 2028 from different projects.
Yeah, so the original funding comes from a European funded project by the European Commission. So it is funded with public money. And of course, then the results should also be public. And we chose Eclipse Foundation because it is now a European foundation. So that matches well together. That's why we decided to make it an Eclipse project, and so far it works very well.
So about the catalogs in the different models that you have prepared, those are contributions from the different research projects? And
Yes.
I will check it out later to see the models, but I was curious about what else is there to offer in terms of running models that we could use.
Yes. And so, if you have any questions, please feel free to contact me. Of course, the slides will be uploaded, the presentation as a video will be available. So if you want to contact me, I'm happy to help you. Okay.